In the last section, we looked at the relationship between the angles formed when two chords intersect at a point on the circle and the arc that they intercept. And today we're going to look at the last of all of the arc and angle relationships that exist when we have lines and segments intersecting in, on, around circles. Okay, so to start with, we're going to look at the relationship between a tangent and a chord and the angles that those form. All right, so if a tangent and a chord are intersecting at a point on a circle, like right here, at point A, they are intersecting. I remember tangent line intersects circle at exactly one point, chord crosses through twice. Then the measure of each angle formed is half the measure of the intercepted arc. This is the same as what we did in 10.4, but in 10.4, the angles were formed by two chords that were both inside the circle. Now we have a single chord and then a tangent line. We still have a vertex that is on the circle though, meaning the relationship is still going to be the same. So with this type, this angle was equal to half of this arc, and the same relationship exists here. So this angle is going to be equal to half the measure of this arc, and then angle 2 is going to be half the measure of its intercepted arc. Okay, so writing that down, the measure of angle 1 is equal to half the measure of, of arc BA, and measure of angle 2 is equal to half the measure of arc BCA. Reminder that when we use three letters, or when we have a semicircle or a major arc, we do need to use three letters to indicate that we are going the long direction between 2 points instead of the shortest direction. Okay, so if we have, let's look at a couple examples. If we have angles where the vertex is on the circle, either formed by two chords or a chord and a tangent, then we are going to set up a relationship where the angle is half of the arc. And because different parts could be unknown and different parts could be known, or maybe we have variable expressions, I would recommend that you use that relationship to write an equation. So like measure of the angle, whatever, equals half of the measure of the arc, and then fill in your missing piece. Okay, so here the measure of angle 1 is half, and then its intercepted arc, this one right here, is 210 degrees. So then that I can simplify to 105 degrees. Okay, here we're looking for RST, which is the major arc, but I'm still going to set it up the same way. Angle is half the arc. And then to get the arc by itself, I'm multiplying both sides by 2. Sorry, there's a bell. And so we get that the measure of arc RST is equal to twice 98, which is 196. As you're doing these, make sure that they make sense. So this appears to be a little bit bigger than half of a circle. Okay, so does it make sense? 196, a little bit bigger than 180? Yes, it does. If I had divided by 2 instead, like if I have these numbers switched and I just thought I always divided my number by 2, I would have 49, and there's no way that that's 49 degrees, because that would only be, roughly an eighth of the circle, but this is clearly more than half. Okay. And then measure of arc XWY. So X to W to Y is going this way. So the angle, now I don't yet know this angle measure, but I do need this angle measure. Remember that linear pairs are supplementary. So if this side over, sorry, if this side over here is 80 degrees, then this one over here is going to be 100 degrees because they add up to 180. So then angle is half of the arc. XWY, okay. So once again, multiplying by 2, so the arc is 200 degrees. Okay, and I'm going to remind you again, writing full equations Number one is how you're going to get all of your points on an assessment, but number two is how you're going to keep these straight as you are answering questions. And you're more likely to get a right answer. Okay. So if we have two secant lines, remember secant lines intersect circles twice. If we have two secant lines, there are three different ways that the two lines can intersect that involve circles. They can intersect on the circle, which is what we've just been talking about. They can intersect inside the circle, which when they intersect inside the circle, we usually see this as two chords because we are just looking at these two pieces. But keep in mind, we could extend a chord to turn into a line at any point, or they could intersect outside the circle. All right, so of those three different places where the two lines could intersect, we have three different kinds of relationships between the angles that are intercepted, such as this one or these or these. Okay, and so we're going to go through all of those and then kind of write a summary chart to help us keep these straight. So if the angle has a vertex that is inside the circle, meaning we have two chords that are intersecting, or secant lines if you were to extend them, but we're only worried about the part that's inside the circle right now. So right now the vertex here is on the inside of the circle. Please notice that that is not the same as being at the center of the circle. At the center of the circle is a possibility, and this theorem would still apply, but if it was a central angle where the vertex was exactly at the center, then we already know that the angle would be equal to the arc because it is a central angle. So this is useful for two chords that intersect anywhere else. Okay, so our theorem here says if two chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the arcs that are intercepted, and it's by that angle and its vertical angle. Remember that vertical angles are congruent. So I know that's a lot of words here, but let's look over here. We have angle 1, and angle 1 is congruent. My pen will write. Angle 1 is congruent not to angle 2, but to this angle over here because they are vertical angles. So then the two arcs that are associated with these two angles or intercepted by those two angles are DC and AB. Okay, so we are using two different arcs here, but the two arcs are based on the intercepted arcs of the vertical angles. So the measure of angle 1, okay, measure of angle 1, which is congruent to this one over here, that's unnamed, is going to be half the sum of these two intercepted arc measures. So half of, use parentheses here, it does make a difference, of arc DC, oh, I forgot my M, the measure of arc DC plus the measure of arc AB. Okay, so once again, half the sum. I do need to, if I'm trying to find the measure of angle 1 and I know those arc measures, I need to add them together, divide by 2, and then that gives me the measure of angle 1. Okay, so be careful with parentheses there. And then for the measure of angle 2, this angle down here, its vertical angle, and I'm not using arcs to mark these congruent. This is just me making a note of which arcs and angles I'm talking about. So this one intercepts arc BC, and its vertical angle intercepts arc AD. So now the measure of angle 2 is half the sum of arc BC and arc AD. Okay. Let's go ahead and do the last one, and then we will kind of summarize. We'll do some examples and summarize all these. So angles that are intersecting outside the circle, which is, remember, the last of the three types. So now we're going to look at this one right here. And so this is this could happen a few different ways, but the important thing is the vertex outside the circle? Okay, could be a tangent line and a secant line, could be two tangent lines, could be two secant lines. It does not matter. If the vertex of the angle is outside the circle, then the measure of the angle is half the difference now, not half the sum like when it's two chords, half the difference of the measures of the two intercepted arcs. So for angle 1, we have intercepted arc BC and AC. So the measure of angle 1 is half, and then difference means we're subtracting. So the measure of arc BC minus the measure of arc AC. For angle 2, we have these two intercepted arcs, so half the difference of arc PQR. I am using 3 letters there because that's a major arc. Minus half the difference, so minus the measure of arc PR. And just a note on this one, you'll notice together these two are 360 degrees. We're not adding, we're subtracting, but frequently they only give you one and you need to subtract from 360 to get the other one. Okay, so that will show up a lot. And you might say, well, where's the other arc? We can subtract. And then here we have two secants intersecting, so the measure of angle 3 is half, again, the difference, and now we're looking at this arc and this arc. So the measure of arc XY minus the measure of arc WZ. Okay. So let's do a few examples. What we need to do is we need to ask ourselves, where is the vertex? Is it on the circle, in which case angle is half the arc? Is it inside the circle, in which case the angle is half the sum of the two intercepted arcs? Or is it outside the circle, in which case we are using half the difference? All right, so for number 4 here, value of x is the angle measure of two chords that are intersecting inside the circle. My vertex is in the circle, so I'm using half the sum, okay? And I'm going to say that whole sentence to myself from the theorem, not like with the letters and such, but just the relationship, because that's going to help me write a correct equation. So the angle is half, and then the sum, and then I fill in my two intercepted arcs, which are this one, and because of the vertical angles, this one. So 92 plus 50. And then I can simplify that. So half of 92 plus 50 is 142. Half of 142 is 71. So x is 71. By the way, if there's already a degree symbol on here and we're just solving for x, you don't have to have the degree symbol, because that would be kind of like saying 71 degrees, but it's not incorrect if you include it, okay? If it just says find the measure of an angle, though, or an arc, and you do not put the degree symbol, then you may not get all of your points on an assessment, because that is not correct. Okay, so here, x is an angle, and the vertex of the circle is on the outside of the circle, so now I'm using that the angle is half the difference of the two arcs. Okay, so let's make sure I know the arcs first. I know that this one is 111. This one right here is not known, but I do know that all of them together are going to be 360. So let's go ahead and find the measure of arc QP first. So the measure of arc QP is going to be 360 minus all of these added together. 104 plus 104 plus 111. Okay, so 360 minus, so that's going to be 208, 308 plus 11 is 319. So 360 minus 319 is 41. So this arc measure is 41 degrees. Okay, now we can solve for our angle. So the angle is half the difference of those two arcs. So 111 minus 41. So half of 111 minus 41 is 70. So x is equal to 35. Okay. Here we have two lines or two chords that are intersecting inside the circle. So now we're going back to half the sum like we did on example 4. So we need the angle to be half the sum of the two arcs. Now here's the thing though, this arc does not correspond to this angle, okay? Neither does the 80 up here. So we need to figure out one of these two angle measures, which vertical angles are congruent, so they're the same, okay? So we're gonna do that by using linear pairs. I do know that these two together make up a straight line. And so we know that this is 180 minus 94, which is 86 degrees, okay? And then the other one's 86 as well. It doesn't matter which one you find, but you do need the angle that corresponds to or that is subtended by the arc in question. Okay, so then the angle is half the sum of the two arcs. Okay, now to solve for this, I'm not going to distribute. I'm going to multiply both sides by 2 to get rid of this fraction. If I distribute, I'm going to have to multiply by 2 later anyway, so I might as well do one less step. Multiply both sides by 2, we get 172 equals x plus 80, subtract 80, x is equal to 92. Okay, so last thing here, we've got, and then we have several examples. I'm not going to go through all of them. I'm not going to go through all of them on the video. I'll do at least one, and then you can check out the answer key because this video is already 16 minutes. Okay. So here's kind of our summary chart for the angle and arc relationships. And remember, everything is based on the location of the vertex. Is it on the circle? Is it inside the circle? Is it outside the circle? We're also going to bring back center of the circle just for a little reminder here. So in the case of a central angle, the measure of the angle is equal to the measure of the arc. So the angle equals the arc, okay? I'm not writing full equations here. I don't have any labels with like letters or any points or anything like that. So this is just helping me remember in words. These are the sentences that I'm saying as I'm writing the relationships, as I'm writing the equations, okay? If I have a vertex that is on the circle, either two chords or a chord and a tangent, then the angle is half the arc. Okay, and then if I have two chords intersecting inside a circle, remember we actually have two pairs of vertical angles here, but let me just, for labeling purposes, look at this one. So now the angle is half the sum of the arcs. Okay, half the sum, like that. And then if, but either because of two tangents, a tangent and a secant, or two secants, the vertex of the angle is on the outside of the circle, then it's half the difference. So the angle is half, and then the difference of the arcs. Okay? So I'm saying this in words because it's not so much a formula with like A's and B's, and because we can get turned around because different circles are labeled differently. It's about the relationships conceptually, because if I say these sentences, then every equation I set up should be correct. Okay? So let me show you again a couple examples here how we're going to use this. So here I have x is an arc measure. I'm looking for the measure of arc BD. I'm given an angle that is outside the circle. So I'm using this last relationship over here where the angle is half the difference. Okay, so the angle, which is 35 degrees, is half, and then the difference between this one and this one, and if it's a question of like how do I know which direction I'm subtracting, if x is a variable, so I don't know if it's bigger or smaller than 100, it's smaller. The one that's further out has to be bigger because that's how angles open. So 100 minus x. Okay, I can solve for this. I'm going to multiply both sides by 2 to get rid of the 1/2. So 70 equals 100 minus x. And then I will add x and subtract 70, or I can just think through this. 100 minus what equals 70? X is equal to 30. Okay? I'm going to let you do number 8. I'm going to do number 9 and then have you guys finish the rest of them. And you have an answer key to check. So here we have two chords that are intersecting inside the circle. So the angle is half the sum of the arcs. Okay? So I'm saying that sentence to myself as I'm writing. Angle is half, and then the sum of the arcs, and the arcs are 7x minus 6 plus 27x minus 6. Okay, so arc. All right, I'm going to multiply by 2 to get rid of the fraction, so 260 equals, and then let's combine some like terms, so we have 34x minus 12, add 12, we get 272 equals 34x. And then I'm dividing by 34. I don't know 272 divided by 34 off the top of my head. I do know 8 times 30 would be 240, so I'm going to try 8. Let's just check. 8 times 34, which would be 240 plus 32. Okay, found it. So x is equal to 8. Okay, so there's a few more, 3 more here, so try those and check your answers. And if you have any questions, let me know.